Welcome to Math is Beautiful. In this video, we see what a matrix actually does. Not a grid of numbers, but a transformation of space, and its columns quietly tell you the whole story. What does a matrix actually do? Not as a box of numbers, as a machine that moves space. Here is the plane, with the two basis vectors and the unit square they span. Here is a 2 by 2 matrix, 4 numbers in a box. The usual rule says multiply rows by columns and stops there. But what is this object really? Watch what it does to the plane. First, meet the two most boring vectors in the plane. I hat, 1 step right, and j hat, 1 step up. Every other vector is built from these two. 3 steps right and 2 up is just 3 I hats plus 2 j hats. Now the secret that unlocks everything. The columns of the matrix are simply where these two vectors land. First column, I hats new home, 2, 0. Second column, j hats new home, 1, 1. This is important, keep it on the side. Why do two landing spots decide everything? Linearity. If your vector was 3 I hats and 2 j hats, where it lands follows the same recipe with the landed versions. 3 of I hats new home plus 2 of j hats new home. Test it on the corner of the unit square, the vector 1, 1. 1 copy of 2, 0 plus 1 copy of 1, 1, 3, 1. And notice, this is exactly what row times column computes. The row times column rule is linearity in disguise. Now watch the whole unit square travel. Its 4 corners follow the recipe, and the square lands as this parallelogram. Straight lines stay straight, the origin stays put, the plane is stretched and sheared, all in one motion. So this is what a matrix is. Not a box of numbers, but a motion of space, and its columns are a complete diary of that motion, because they record where the two building blocks went. Now let's look at an application of this concept. A matrix sends I hat to 0, 1 and j hat to -1, 0. Where does it send the point 2, 1? Read the given landing spots and picture them. I hat, which pointed right, now points straight up. J hat, which pointed up, now points left. Keep them on the side. The point 2, 1 is a recipe, 2 I hats plus 1 j hat. Apply the parked landing spots to the recipe. 2 copies of 0, 1 is 0, 2. Add 1 copy of -1, 0. The point lands at -1, 2. And step back, right went to up went to left. Both building blocks turned a quarter turn, so the whole plane did. This matrix is a 90-degree rotation, and 2, 1 landing on -1, 2 is just that turn in action. So a matrix is an action on space, and its columns are where the basis vectors land, read them, and you can see the transformation before you compute anything. Thank you for watching. If you found this video helpful, do like it, subscribe to Math is Beautiful, and share it with your friends.